Alrighty, so let's see what cute little Kendall's doing over here. Well, apparently she's drawing pictures. Looks like she left something off. What are you saying?
Oh my god!
What are you up to?
Okay. So we got the level system back up.
Right.
And it's not synced up with Marauder's level editor yet. That's gonna come later.
Yeah, we haven't actually had time to play with it.
So right now I loaded a level manually, and
as in she literally like wrote out ones and numbers and text files.
But this is what it looks like right now, and you can see our collision system demonstrated here. Whenever I'm colliding with this blue rectangle right there, the screen flashes red, indicating that a collision was detected.
Which is an oriented bounding box.
And you can see I still have control over this guy, and I can push this other one around.
See, the thing is, with the old engine, we didn't actually have collision covered for two oriented bounding boxes. We just had them for axis aligned, so you couldn't actually rotate two polygons like that. Show us your little sprite sheet you made.
Okay. I just like
drew little girls in the wire.
Threw together some sprites to make this little underwater level that I showed off a second ago.
Cute. Alright, Kendall, you go, girl.
So we're using the separating axis theorem in our collision detection algorithm to test for collision between two oriented convex polygons. You can understand the separating axis theorem with basic geometry and a shitload of linear algebra. What the separating axis theorem tells us is that if we can find an axis along which the projections of the two polygons is not overlapping, then these two polygons are not overlapping and thus not colliding. Each of the axes is perpendicular to a face on each of the polygons. The nice thing about using rectangles is that each face on a rectangle is parallel to another face, so the total number of axes that you have to check for collision for is only 4.
And a smart person would know that when you're projecting these polygons, the axis itself should be normalized so that you can just use the dot product or scalar product with each vertex on the polygon and the normalized axis. Right, Kendall?
Right, Falco.
Okay, so I'm going to be demonstrating our new fancy collision detection system. So first of all, we have a general collision function, which takes references to two rigid bodies and checks their orientations. And if their orientations are aligned, if they're axis aligned, then it goes over here to the fast axis aligned collision detection. And if they're not, then we jump over to the oriented bounding box collision function, in which we implemented the separating axis theorem. And this function also takes two references to two rigid bodies, and it's going to return us a normal vector. And we're going to use that normal vector to push the other rectangles around. Like you can see I'm doing here, I'm getting input from the keyboard, and I'm controlling this pink one over here on the left. And I can change its orientation, or stretch it, or make it wider, or turn it white if I want to. And this is just a collision system right now. It's not actually the physics system. It's going to be the backbone for the physics system that we're going to implement later, but even as it is right now, it's still pretty neat.
Alright, so as you all should know, Marauder's making the new level editor since Marcel decided to quit. Here he's browsing the repositories, looking for the latest build, and I think you'll notice that it looks fairly similar to Marcel's right here, except for it's a lot sleeker, more stylish, and it runs quite a bit better. It's been rewritten in C# versus Blitz Plus, which Marcel's was written in. You can see all the fancy options that are new. The panel on the left over there is completely new. Here Marauder's demonstrating basic tile laying capabilities and disabling, enabling layers, stuff like that. Here you can see items, which Marcel's level editor actually never got to work. These are things you could pick up and throw around or interact with the basic physics system in the old engine. As you can see, you can lay them now in Marauder's editor. Here's a cool addition where he can edit tile sheets and then reload them at runtime without having to restart the application or reload the level. I'm sure that'll come in handy for the pixel artists and sprite people.
So Pritam is our new graphics artist, currently in Sorrento studying art and working on concepts for Elysian Shadows. Here you can see some of his architecture concepts. And some colored armor for the Ancient, the finished product of the Ancient after a dozen or so attempts, finally perfecting his look. And here's the beginning of the concept for the Fallen Angel, who's going to be joining your party later in the game, and the final product of the Fallen Angel.
Okay, so as you all should have cleverly deduced by now, the Elysian Shadows engine is being rewritten to support Sega Dreamcast, Sony PSP, and the PC. And I haven't really gone into any specifics as to how it's going to do that, and I just wanted to cover that. Here's our application, Elysian Shadows. This is the game itself, this is the engine itself. Now, most engines, most games, what have you, would make calls to OpenGL or SDL or something like that to interact with the hardware, a graphics API, something like that. But my goal is to create my own library so that our flow is more like this. Elysian Shadows goes to libgyro, which is going to be my own homemade library because, to be bluntly honest, I stole Vorbis from a certain OGG decoding library. And now, Elysian Shadows, instead of calling OpenGL, draw quad, whatever you do with OpenGL or Dreamcast or PSP, I make hardware calls to libgyro, and then libgyro takes care of that by handling 3 different scenarios. So for the PC version, you should know that we use SDL and OpenGL. So if I invoke libgyro and it's being compiled for PSP, it should make SDL and OpenGL system calls. If it's on Dreamcast, it should make Chaos system calls, which is the homebrew SDK for Dreamcast. And PSP, I'm pretty sure it's just called PSP SDK. And so now I have a generic draw quad function which resolves to one of these depending on the console or something. And then these in turn go to the hardware. So you have a cute little PC here, which you're rendering to with that. Chaos, you have a Dreamcast. And then PSP SDK, that is the ugliest PSP ever, renders to PSP. And so now the goal is that you can create an application completely independent of whatever platform you're trying to compile it for. And we've also been considering releasing this to the public. For example, when I finish this, or get far enough along on the game, I might release it so that you guys can also use this library, and your application will work on Dreamcast, PSP, and PC just because you link to it. If you have any comments on that, or if you'd be interested in that, let me know. It probably won't happen until the future when I'm a little bit farther done with it, but I am considering that to contribute something useful to humanity.